All right, here we are in Desmos. I have already preloaded the data points for the constant acceleration lab. This is just sample data that a student group might have collected. You can see I put the data in to a table that already had a T at the top in the left-hand column and a D at the top in the right-hand column, and those are for time and distance. And again, this was the constant acceleration lab, so students were rolling ball bearings down ramps. So I've preloaded the data, and you can see it in the display in my Desmos. And I would encourage you to go ahead and take the data and open up your own Desmos and try this out. Once I enter in the data, you can see Desmos is automatically creating some error bars. The teacher has done something on their end to make that appear for the students. And I look over to the left-hand side and I see C equals 0. So, and right below that, I see a few different mathematical models relating different ways that distance and time could potentially be related from our data and in this experiment. I see D equals CT in the red, D equals CT squared. We'll have a blue, and D equals C divided by T has green. And as I take this C equals 0, as I take this dot and I slide it over, I start to see some lines pop up, and the blue, red, and green lines relate to each of those mathematical models and those relationships that they express. So I'm going to keep sliding it over until I find a model that matches the pattern in my data. And as I slide, I can see that the green line definitely does not match. The red line's going through a couple data points, but definitely not all of them. And here I am with the blue line, the blue curve is matching up with my data. So I'm going to look over here and see, okay, this red line is a proportional relationship and it doesn't match with my data. And this looks a little noisy, so I'm going to exit out and get rid of it. The blue line does match with my data, so I'm going to keep that relationship up. And the green line, again, doesn't match, and I'm going to get rid of that. And now I have, can see pretty clearly this C value slider. I can adjust it so that I think I get the best fit of going through as many points as possible, with maybe some a little above and some a little below. And I can see on my screen, it says right in mathematical model here. So I'm going to go down to this place right here, and we encourage students to use the words so they can really make meaning of what the mathematical model is showing them. And in this situation, I'm going to write, instead of D, I'm going to write the word distance equals, and C, I actually have a C value here. It's 1.28. And then I'm going to use a star for times. And time squared, we encourage students to actually write out the word time and then another multiplication symbol, star, and write time again. So I can see that the relationship for my constant acceleration lab is that the distance is equal to 1.28 times the time times the time. This helps students build a pattern around the quadratic relationship and then attach it to a physical experience of a ball accelerating down a ramp. This is part of Unit 2 in our physics curriculum. And thanks for taking a look at this so you can see an example of how students use their data collection and experimentation to find patterns in data. Following this activity, students would compare with other groups that may have had a slightly different experimental setup, and they would notice that they all came up with a quadratic relationship. However, they might have different C values. So they would start to explore the similarities and differences between their experimental setups to see how a different experimental setup related to a different C value, to start to understand the relationship in the mathematical model of what would make that model change and how it connects to the experience. Thank you for looking at this video.